In this exercise, we'll demonstrate the usage of the quasi-dynamic simulation. Activate the quasi-dynamic simulation study case. This diagram has been colored to show the different network feeders. Zoom in on the network diagram as shown. We are going to take a closer look at the feeder illustrated. This feeder is called FD125. A schematic diagram of this feeder is available on a different tab. Select the tab. This diagram shows all the loads and the PV systems connected to this feeder schematically. Let's take a closer look at one of the LV loads. Change to the load flow page. Notice that a yearly energy consumption in kilowatt hours has been defined. Notice also that consumption profile has been set. Different characteristics can be defined depending on the day of the week as well as the season. Now let's take a closer look at a PV system. Notice that a solar calculation model is used to calculate the in-feed of the PV system. This means that the power in-feed is calculated based on the expected irradiation for a particular GPS position as defined in the bus bar to which the PV system is connected. Now we will run the quasi-dynamic simulation. Go back to the 400-volt diagram. Press the quasi-dynamic simulation command icon. Apply the time period 28th of April 2014 to 5th of May 2014 and choose a time step of 1 hour. Press execute. The diagram has now been colored according to voltage and loading. We can better illustrate the results graphically by running the heat map command. Set the resolution to high and the color to green. Select execute. The lines which are overloaded are now clearly visible. Now run the quasi-dynamic simulation loading ranges report. Select loading ranges and choose the complete time range. Execute the report. 3 lines are loaded above 100% of their maximum loading. Mark the most heavily loaded line in the graphic. Choose the feeder schematic. The heavily loaded section of line is marked. It is clear that all 3 overloaded lines are in the same feeder. Right-click on an overloaded line, choose the option Show, then Plot, and then Loading. Here you can see the loading profile for the line over the time period of interest. A line is overloaded if its loading is above 100%. Set a constant to illustrate the 100% level. We can also label the point in time where the overload occurs. The highest overload is approximately 107% and occurs at 1 o'clock on the 3rd of May. Choose the PV Active Power tab. The active power generation of 3 different PV systems is illustrated. The red curve is a 2-axis tracker. The green curve is a fixed installation. Change to the Feeder Voltages tab. Here you can see the maximum and minimum voltages within the feeder within the time range. Choose the Load Active Power tab. Working day profiles are illustrated here. Thursday is a holiday. Saturday has a high evening load for residential customers. We can see the energy consumption of the loads during the time period of the quasi-dynamic simulation. Go to the flexible data page and here you can see the energy parameter. Additional parameters are also available if you define flexible data. Statistical parameters are illustrated here. All power quantities can be used to calculate energy values over a given time period. Choose feeder 125 and define quasi-dynamic simulation results for the feeder. Choose the AC balance option. Notice that some calculation parameters are already defined. Gen P is the power of all generation units. P in is the in-feed from external grid, PLD is power of all loads within the feeder, and loss P is the overall losses within the feeder. Define flexible data once more, and it is possible to select the calculated energy values. These correspond with the previously selected power values.